with SAML, which is basically actually integrating CloudStack as a service provider in an identity federation. And basically, to start, before I get into details of CloudStack, because they are pretty basic, I will provide you guys an overview of identity federation, because I think it's very important to understand what an identity federation is and how it can help you to leverage the identity management and authentication management of users in your organization, because that's very important to centralize this kind of management. And just to start a little bit, I don't have a lot of details about me because I really don't like to publish things online about myself, privacy and stuff. Basically, I'm a committer in PMC for CloudStack. I started working with CloudStack in 2013, so it has been a long way down. And I help people organizing the CloudStack Collab that happened in Brazil this year with the developers conference. So what's the goal of the presentation here? Is to understand what an identity federation is, because sometimes people try to adopt this kind of technology, but they don't understand what it means and what it is used for. So that's one of the goals. Then to talk about the protocols and systems that you can use to implement an identity federation, because one thing is CloudStack and one thing is to integrate CloudStack with a system that's already set up. Another thing is to understand what kind of protocols and frameworks you have there to implement an identity federation before you can integrate it with CloudStack. So that's the idea here. And basically, I will do then a demo of a CloudStack environment that's running on live with OTP without changing any single line of code in CloudStack. And that's one of the whole ideas of identity federation. You offload the user management, the user authentication, and all of the security stuff to a third party that just knows how to do that. It's not just that, there are more things, but that's one of the excuses to use an identity federation systems. So to start, I like to get everybody on the same page, and all of these, formalization comes from my background. I'm actually from the academia, and my master's, for instance, was in identity management, more specifically with identity federation, and more specifically with security and privacy. That's why I don't like to publish things online. So just people can understand why, and don't think that I'm like a weirdo. Basically, when we are talking about identity federation and user authentication, we are talking about access control. And access control models, what they try to do is to manage the access to sensitive resources. And in our case, sensitive resources means virtual machine, volumes, and snapshots. Those are the sensitive resources that we are managing, basically. When I say we, I'm talking about CloudStack or even other cloud computing orchestration systems. And the idea of the access control here is to guarantee the confidentiality, meaning that only people that are authorized to access those information are in fact doing that access, and also integrity, meaning that no unauthorized party is changing that data. And basically they come in different models, the ancient ones, mandatory, discretionary access control models, and then we have the more recent ones like role-based access model, like the CloudStack has implemented on it. And then we have the evolution attribute-based access control model, which is not just based on the role of the user, but also in a set of attributes that describe the users in a given context. And that's why it's more flexible, because you don't have just like a single attribute to decide if the user has access or not to a resource, but you have a set of attributes. And then we have what in academia, because we keep going on, right? We are now studying the academia, not we, because I left academia, but like they keep going on, and now they study more or less the risk-based access control model, which is based on probability, which provides even more flexibility. But of course, you are working with probability, so it's not a sure thing. And whenever we talk about identity federation nowadays, we are talking about attribute-based access control model. So it's not RBAC, it's not role-based access control model. And the idea of the attribute-based access control model is it uses user attributes. These attributes, they are information that's used to describe users in a given context. And basically, we then have a set of rules that are applied against these attributes to decide if the user has access or not to a resource. And in this context, we have something that we call identity and access management systems, which is like the ecosystem where we have identity provider and service provider. I will talk a little bit more further about them. And we also have some other entity which is called identity, which is a set of attributes. The name of the attributes that is identity, a set of attributes that describe a user. So to illustrate and to go a little bit deeper, so in an identity and access management system, we normally have these parties here, these entities. So we have users that are trying to access resources. We have identity providers, which are the parties that are managing the user attributes, the user authentication, and even the user authorization sometimes. And then we have the service provider. Service provides any kind of application that is delivering a resource that the user wants. CloudStack, for instance, can be considered a service provider because it delivers resources such as virtual machine, volumes, and so on for users. GitLab is a service provider. The difference is that they provide different kinds of service. But anyways, they all can be considered a service provider. And then we have an identity, which is just a set, a group of attributes, key and value, that are used to describe a user in a context after the authentication process. And just to give the context as well, basically when we talk about access control, we have the traditional way of doing it. That's how CloudStack started doing it. So the service provider, the application itself, is handling the user information and the user authentication, authorization, and so on. That's the traditional way of doing it. And then as companies started to deploy more and more systems, they started to create this idea of the identity provider, and then a single administrative domain, which means in a single organization, we have just one entity which is managing the user information and authentication, which is called the IDP, identity provider, and then we have all of the other parties executing, offloading the authentication there. And why do you do that? Because you want single logout. You don't want to spread user accounts everywhere, and you want a centralized user management. So you can have the same authentication policies, password policies, and so on for all of the users, for all of the systems. And that only works in a single administrative domain. But as the world grows, companies start to interact with each other. You need to federate somehow these systems. And the idea here is that the user from one company, from the domain administrative, is accessing a resource in another domain administrative while authenticating the home domain. So the user Bob here from domain administrative A can access a resource in domain B, a service that's provided there, while executing the authentication at his home domain. And why is that important? Because you don't send your credentials and passwords and so on to the domain where you are accessing the resource that you requested. And that's quite interesting right nowadays, with GDPRs and with all of those regulations regarding user data management. So whenever we talk about identity and access management in a federated environment, we more or less have two ways of implementing it. So basically that is like one of the first protocols and standards that was created. It's called Security Assertion Markup language. For short, you can call SAML. And it basically uses XML to describe the messages that are exchanged between the parties. And they adopt the public key infrastructure to create a trust between the different parties in the ecosystem. So they know that the messages are authenticated, because of the public key infrastructure. That's basically, I don't know if all of you know, that's like cryptography, and more specifically asynchronous cryptography. So you have public and private keys that are shared between the parties, and so they know that the messages came from a trusted party, and that's why you can trust the authentication process that was executed in the IDP, because you do trust it, and you check that the message was generated by that trusted identity provider, so you can just move on with the user without requiring a new authentication process in your service provider. And this standard is developed and maintained by an organization that has a very nice name, which is called OASIS, which stands for Organization for the Advancement of Structured Information Standards. And they keep developing it. I think there was a version 3 some years ago that was released, but I'm not sure if they are moving on right now. But for sure there was a version 3 for some years ago. at least when I was doing my master's, that I checked that they were developing, but I don't know if it was released already. And then there is OpenID Connect. They both do the same thing. OpenID Connect was built on top of OAuth, which was the protocol created by Google, 2.0. It uses public key infrastructure as well, but the difference is that it adopts JSON as the format to exchange messages between the parties. And this OpenID Connect protocol is maintained by the OpenID Foundation. And why a lot of people questioned me when I was doing my dissertation, why do you need a second protocol when you have one that already works? And OpenID Connect was created when the mobile device in 2014, they started growing the usage of internet services. And when you are parsing data in a mobile device, XML data in a mobile device, that costs quite a lot of processing power, and that means battery consumption. So basically, OpenID Connect came to solve this problem, to reduce the usage of battery in mobile devices, because it's quite faster to pass than XML. But they both can be used at the same time. And basically, to implement those protocols, we have these frameworks and systems. When I say frameworks, it's because, for instance, the Mitri ID Connect there, which is the implementation from MIT, from the I forgot the name of the laboratory there, but they implement the OpenID Connect protocol. That's just a framework, but you have, and then based on that framework, you can create your identity provider and service provider. But we have alternative solutions such as Shibboleth, which is a full-blown service provider that you can use to control the access to applications. And we have Keycloak, for instance, which is a full-blown identity provider where you are able to manage user information, user session that you have authenticated in different systems, user passwords, OTPs, and so on. And the interesting part of Keycloak, that's the one I'm using in the demo I will show you guys. It can work with both SAML and OpenID Connect at the same time in the same identity provider. So if you have service providers that, for instance, CloudStack only work with SAML, and there are some other service providers like GitLab. GitLab only works with OpenID Connect, so you would have a problem depending on the technology you adopt. And Keycloak is quite flexible in this manner, and it's open source, and of course it's maintained by Red Hat. But anyways, it's open source and it's out there, and it's quite nice the software they developed there. So in CloudStack, it only supports SAML, and basically this is quite nice the way the implementation was created there, because you just need to enable and disable some parameters at the global settings configurations. And basically you just need to look for the SAML configurations there. And then you're going to see all of the important configurations for you there. The most important one is, of course, the true and false to tell if you are using or not SAML, federated authentication. And then we have this one here, which is SAML IDP metadata URL, which is the address where CloudStack can locate the metadata, which is the information that describes each one of the identity providers and service providers that you have in the federation. In this metadata, you have the keys, for instance, that they exchange to build the federation. And when I say keys, I'm talking about the public keys, right? Because that's how the parties can validate the messages, for instance. And then we have a bunch of other configurations there, such as the hashing mechanism used for signatures, some naming stuff there, how we are calling the CloudStack service provider, and so on. But it's pretty straightforward. Okay. All right. Yeah. So that's basically it. The idea of the identity federation, the protocols, and some basic overview on the frameworks and systems that one can use, and how to use and configure it in CloudStack. And then let's see if we can do a demo here. So this is CloudStack here. I already configured this CloudStack environment to authenticate using my identity provider there. And I configured my identity provider also to trust CloudStack, otherwise it would not work, because the trust, it needs both ways. Let me go there and see if everything is going to work. So, all right. And basically, when you enable that, CloudStack will read the metadata file that you configure there, and this metadata can have as much identity providers that you need. In my case, I just have one. And then you select it and you tell CloudStack that you want to log in with it, and then it will redirect you to the identity provider. That's where you are actually going to execute the authentication process. Then you execute the login there. As soon as the login is executed successfully there, you are redirected back to CloudStack. And then you are there and you access your account in a transparent fashion. Now let me do something different. Let's enable OTP, for instance, because nowadays every single system should have OTP, but it's quite a burden, to implement OTP in CloudStack nowadays. Why do we need to implement it if you can have like a system like this, if we offload the authentication process? So let me just configure for my account there. Alright, let me delete this one. Yes. Okay, so I just registered my OTP authenticator there in the CloudStack environment, not in the CloudStack environment, but in my identity provider there. And now if I try to log in again, here, it should ask me for an OTP code before authorizing me to access CloudStack. Yeah. So before I'm able to access CloudStack, I will need to provide an OTP code. Okay. Yeah. So why is this interesting? Because I did not need to code anything, so it's already there provided. And not just that. If we access that system from an admin perspective, we can see all of the sessions that are open for all of the users, and we have a centralized way of managing it. And of course, not just that, because it's a very sensitive system, an identity management one. We have audit logging for every single thing that happens there: password updates, email updates, user attribute changes, authentications, logouts, everything. You have audit tracking there, because in my opinion you do need that, especially if you run a very critical environment. And there is something quite interesting as well, because it's a federated system. You can have multiple stacks providers there. So I do know that some people don't like OpenStack, but sadly I have to work with both. And I do have another OpenStack environment there that's up and running. It should be up and running. And it's configured to use the same identity provider there. So technically, or in theory, I should be able to access OpenStack in a transparent fashion without needing to authenticate again, using the same identity provider that I use it for CloudStack. I just don't know why it's not working. Well, I just tested this morning and it was there. Yeah, shit. I don't know what happened. Yeah, the idea was to show the authentication in OpenStack, because in OpenStack I'm using OpenID Connect. So I'm using the same identity provider with two different service providers. These two different service providers, one is using SAML and the other one is using OpenID Connect. So that was the idea. That's why it's interesting to see it working. But yeah, I don't know, my internet here is not that great. And that's basically it. So what are the benefits of this kind of approach when you offload the authentication user management to an identity provider system? The first one is seamless integration with partners. And this is something I did not talk a lot about, but it's like, depending on how you run your business, it might be more interesting to have the client holding the user data, and then you just offload the authentication, the authorization process to there, because then you reduce the responsibility because you don't need to manage user data. I mean, they are executing the authentication process. If there is somehow, if a user uses a weak password, it's their fault because, you are delegating all of the authentication authorization process there. You also reduce the number of accounts, of course. Yes?
Can you do this at the middle level?
In CloudStack?
But shouldn't it be? Because then that will say, I have one CloudStack, one domain, one provider.
Yeah.
And enterprises can connect to their.
Yeah. That's a good question. And that's one of the problems I will talk about actually. Because in CloudStack, when this I can show you guys. Let me see if my things is working here. This is something that's not working as that great in CloudStack. When I'm enabling users to authenticate themselves in an identity federation system, I have to manually create the account in CloudStack, and then I have to configure it here on one of these buttons. This one. So I have to configure it here, and then I tell this user can authenticate with that identity provider. So it's being done in a user level, and this is something. I mean, that's not following the identity federation principles because in theory the user does not. In theory, not. Actually, if you implement it as it should, if you follow the protocol, the user does not need to exist in the service provider. It should be created on the fly everything. And depending on the implementation the service provider that the service provider has, the service provider only needs to store an opaque something that doesn't represent the user per se. It's just an ID that's generated for that service provider, for that user in the identity provider. This way you can guarantee the user privacy when they are accessing the service. But CloudStack was not implemented with this manner. But if CloudStack were to be extended, then we would be able to do that. And more specifically, I think if we are going if the idea is to fix this, because if we fix this, we can do what you are saying. And in my opinion, it should be done using something similar that OpenStack does this way. So, because CloudStack is the service provider receives a set of attributes that describe the user in that context when they are accessing the resource, and CloudStack can use those attributes to create accounts on the fly. And then you can map, for instance, a domain to an identity provider, and then when the set of attributes comes from that identity provider to users in that domain, the accounts are created on the fly in CloudStack. That would be possible, but it needs to be extended. That's one of the problems I find in this implementation.
And the roles are stored also as a part of the central place?
In the identity provider, yes.
IDP will have it?
Yes, IDP would have it as an attribute.
And is it on a core application level?
You can do that in an application level, yes. Because every application can be managed separated in the identity provider. Yes. My internet's not working here. But in this system keycloak, for instance, we can have different roles for different users when they authenticate in different service providers. That's able to do. That's actually how we are doing in this company where I implemented the OpenStack environment, and then we implemented actually not just the cloud for OpenStack, we implemented the whole federation. And the roles for OpenStack is managed in the identity provider. So then we change. I mean, the only person able to change the attributes there are the admins, not the users.
So if this gets fixed, what are the kind of then I can theoretically have multiple CloudStack deployments acting as one.
Yeah, you could. Exactly.
From the user's point of view.
Yes.
Like still templates and things like that, but at least you can just log in.
Yes, exactly that. And that's why it would be nice to fully implement the protocol there.
How does the account get created in CloudStack?
Right now, you need to create it manually. You need to go there and create the account. There is an API command, or via the UI, you create the account and then you create the user.
Don't we have a similar code in LDAP? LDAP, we have both the modes.
Yes, the LDAP will load the attributes. Yeah, but the problem here, the difference from here and with LDAP is that this process of attribute dissemination is only triggered by the user during the authentication process. So it only happens.
Oh, the flow is
Yes, yeah, it's a different flow. So CloudStack doesn't have access to all of the users that exist there in the identity provider. And this happens because of part of the GDPR that user need to have awareness. So I actually disabled the awareness screen here just to speed up things. But in the keycloak, for instance, if I enable the awareness screen, after the authentication process, the user receives a screen saying, hey, these attributes are going to be disseminated to the service provider. So that's why you cannot grab everything beforehand. You need to wait for the users to execute the authentication process, to do the release of the attributes, and then you can get them and you can do the processing. That's why.
What about the rights that the user has? Like, while creating, you have to specify that.
Right now, yes. Yes, right now the user that's authenticated in the federation will get the right of the account that you create. Because you need to create an account beforehand, right?
So even if I change,
then it won't work. Yeah, no, it won't work. Yeah, and with CloudStack it doesn't work. The implementation we did with OpenStack, it works because OpenStack loads on the fly the attributes. So the idea is to reduce the number of accounts and also to implement stronger and uniform authentication policies. What do we mean by that? In this company where we were working with CloudStack and OpenStack, they don't just have like OpenStack and CloudStack. They had many other systems, and each one of them they have different. They had different password policies, different authentication policies, and they wanted to implement OTP. But how do you do that? I mean, are you going to implement OTP in every single system out there? It's just nonsense. So by adopting this scenario, these technologies here, we were able, to have a standard and common password policies for all of the systems, to enable OTP in a transparent fashion for all of the systems without any coding. We also got auditing the same manner for all of the systems, and we can manage user sessions on the fly. So if there is a data breach, if there is a hacking somehow, we can invalidate all of the sessions. The administrator can do that on the fly, without stopping, without doing anything.
You can terminate?
Yes, we can terminate.
Then how will CloudStack?
Yes, that's part of the protocol. CloudStack did not implement it as it should. Yes, that's part of the protocol. So when you read the specification for SAML and OpenID Connect, there is a hook that the identity provider can call to invalidate user sessions. So that was not implemented. To be fair, OpenStack did not implement it as well, but our requirement, we needed it, so we fixed it there. But I mean, I did not have this requirement for OpenStack, that's why it wasn't fixed here yet. But there is this problem that we were discussing with the user mapping and the user creation, and there is something else. This is open because this is actually part of the research, because you need to change the protocol to deal with it. If the user generates access code or in CloudStack user keys, they are bypassing the authentication process. They are bypassing the authentication process.
If you do what?
If the user generates authorization codes or user...
IDP directly.
No, in CloudStack you can generate user keys.
If you use that, then
Yeah, because then you bypass the authentication process.
then the main user password process is bypassed.
Yeah.
How do you do it?
The user can just go and
No. I understand the problem now. How is it fixed in general API?
No, it's not fixed yet. This kind of problem here, it's an open issue.
For the protocol itself?
Yes, from the protocol itself. That's one of the problems. Because the protocol was...
But how will it work in mobile? mobile, everything is done through APIs, right? Open.
Yes, but then there is the authentication execution flow in the identity provider. But that's something else that most systems are not implementing it. Then you need to authenticate. When you do the authentication in the identity provider, it will generate an access code there in the identity provider, not in the service provider. So that's the problem. And then you need to support that execution flow, which is called, in the case of OpenID Connect, it's called authorization codes. But you need to generate the authorization code in the identity provider, not in CloudStack.
But that will be session specific, right?
Yes.
Sorry?
That needs to be session specific.
Yes. It has a TTL, and then you receive that code, and it has a short time to live, and then you present that code to CloudStack, and CloudStack presents it, and then CloudStack executes the command you want. That's why it's troublesome. That's why it was not implemented here yet, and neither in OpenStack, for instance.
The only thing is, in such cases.
Yes. In OpenStack, one thing that we discussed how to fix it is to add support for these authorization codes in the CLI. Then the CLI, the command line interface, will generate the authorization code, and then we will use the authorization code to execute the requests instead of, for instance, authenticating with username and password. But that hasn't been fixed there as well. But this also generates some other problems with some other systems because they have some asynchronous tasks that are executed automatically on behalf of the user. But some systems, we still have this open problem in a variety of systems. And the single logout, that's what we said that it's not implemented. But I mean, it's specified in the protocol. You just need to implement it and follow it. That's basically all, guys. Thank you all for attending, and if you have any other questions, please. Thank you.